If 1 millimolar solution of ethylamine produces pH is equal to 9, then ionization constant Kb of ethylamine is 10 to the power of minus x. The value of x is, so here it is ethylamine, aqueous solution containing ethylamine, C2H5NH2. Aqueous solution means water is also there. Amine is acting as a base which can accept the proton from water. C2H5NH3 plus, and H2 after donating a proton has been changed to OH minus. In this reaction, ethylamine is acting as a Bronsted-Lowry base. Bronsted-Lowry acid, water. It is a conjugate acid, conjugate base. Initially, ethylamine of the concentration C and water concentration excess will be there. Here it will be 0, here it will be 0. At equilibrium, C into 1 minus alpha, and here it is C alpha, C alpha. Degree of dissociation of ethylamine can be neglected, so 1 minus alpha can be taken as nearly equal to 1. Then C 1 minus alpha is neglected, then Kb is equal to concentration of C2H5NH3 plus, that is C alpha, into OH minus concentration into C alpha by C2H5NH2 concentration C into 1 minus alpha. What is the value of this particular C alpha means? It is already given as pH is equal to 9. At 25 degrees centigrade, pOH is equal to 4. Not 4, that will be equal to 5, because pH plus pOH is equal to 14 at 25 degrees centigrade. Then OH minus concentration is equal to 10 to the power of minus 5. So now Kb is equal to C alpha value can be taken as 10 to the power of minus 5 because OH minus concentration, and this C alpha is also 10 to the power of minus 5. And the value of C2H5NH2, it is nothing but the C nearly equal to 1 millimolar can be taken as 10 to the power of minus 3 molar. So 10 to the power of minus 5 into 10 to the power of minus 5, 1 minus alpha value is neglected, then you can get 1 minus 10 to the power of minus 3. Then 10 to the power of minus 10 by 10 to the power of minus 3, that will be equal to 10 to the power of minus 7. Then the value of pKb is equal to 7 because minus log Kb to the base 10. But here ask the value of Kb only, 10 to the power of minus 7, x value is equal to 7 only. In this question, during the estimation of sulfur, 160 mg of an organic compound gives 466 mg of barium sulfate. The percentage of sulfur in that compound is. So in Carey's estimation, percentage of sulfur is equal to 32 by 233 into weight of barium sulfate obtained by weight of organic compound taken into 100. That will be equal to 32 by 233 into weight of barium sulfate is 466 into 10 to the power of minus 3 grams by weight of organic compound is 160 into 10 to the power of minus 3 into 100. If I am going to do the process of calculation, you can get 40% here. 40 is the correct answer for the given question. Consider the following sequence of the reaction to produce a major product, and we have to find the molar mass of the product. So here it is, the compound metanitrotoluene is given. This metanitrotoluene is subjected to react with bromine in the presence of iron. It is a free electrophilic substitution reaction. The given benzene is having the two groups. One, it is an electron withdrawing group. It is an electron donating group. Whenever you are going to do the electrophilic substitution, you have to do with respect to the activating group, methyl. Methyl group activates the benzene through hyperconjugation as well as this particular inductive effect. So which is a paradirector, and that is a major product, OP director, and para is a major product. And here it is Br, NO2 and methyl group. The bromonium ion attacks the para position to methyl till in the presence of HCl, which undergoes reduction. Then the compound obtained is benzene, which is connected to CH3, which is connected to Br. NO2 has been changed to NH2. Reduction takes place. And now these will undergo the diazotization process. NaNO2 HCl at 0 to 5 degrees centigrade. Diazotization takes place. You can get N triple bond N positive charge Cl minus, and here it will be Br single bond CH3, which is on reacting with H3PO2, a good reducing agent which reduces the diazonium chloride to its corresponding benzene. Then you can get the compound benzene, and here it will be CH3 and here it will be Br. That is the final product obtained, para-bromotoluene. If I am going to calculate the gram molecular weight of para-bromotoluene, you can get 171. So 171 is the correct answer for the given question. For the thermal decomposition of N2O5 at constant volume, the following table is formed, the reaction mentioned below, and 2 N2O5 gives rise to 2 N2O4 plus O2. So the reaction given is N2O5 gives rise to N2O4 plus half O2. That is the first order reaction. So if I am multiplying this one throughout the equation, here 1 by 2. Initially N2O5 pressure is 0.6, N2O4 0, O2 0. After time that will be 0.6 minus x, and here it will be x by 2. So after some time the total pressure Pt is equal to 0.6 minus x plus x by 2. X will be cancelled. 0.6 plus x by 2 is equal to the value is given as x only. So let us consider this value is x1, and here it will be x1, it will be x. So the first order integrated equation, k is equal to 2.303 by time t log initial pressure 0.6 by let it be the final pressure is 0.6 minus x for the reactant. So the k value is given as 4.606 into 10 to the power of minus 2 is equal to 2.303 by time t, that will be taken as 100, into log 0.6 by 0.6 minus x, that will be equal to, so 2.303, here it will be cancelled 2 times, and 110 to the power of minus 2 both will be cancelled. 2 is equal to log 0.6 by 0.6 minus x. 2 can be taken as log 100, then 100 is equal to 0.6 by 0.6 minus x. If I am doing the cross multiplication, 0.6 into 100, 60 minus x is equal to 0.6. Then x is equal to 60 minus 0.6. That will be equal to 59.4. Then the total pressure Pt is equal to 0.6 plus the value of x is 59.4 by 2. Then you can get the total value as 897 into 10 to the power of minus 3 atm. So 897 is the correct answer for the given question. So standard enthalpy and standard entropy for the decomposition of N2O4 and NO2 are 55 kJ per mole and 175 kJ per mole. The standard free energy change at 25 degrees centigrade is, we know that delta G is equal to delta H minus T delta S. The value of delta G you have to find, and the value of delta H is given as 55 into 10 to the power of minus 3, because kilojoules is given but the answer is asked in joules. Minus the temperature T is given as 25 degrees centigrade, change into Kelvin is 298, and the value of delta S is given as 175 joules. So if I am going to do the calculation for this one, you can get 5, here it will be 10 to the power of plus 3, 5,5,0,0,0 minus 52150. Then you can get the answer 2850 joule per mole. 2850 joule per mole is the correct answer for the given question.